Okay, gang, we're back. This will be section 5.2, finite math. This is called a fundamental principle of counting. And I'm going to start off with a warm-up problem. I'm going to give you three sets. Set A is a set whose elements are 1, 2, 3, and so on, all the way up to 20. Set B is a set whose elements are A and B. And C is a set whose only element is the number 8. Simple questions. When I write this, N means number. I want the number of elements in A. So how many elements are in A? You start with 1, 2, 3, and so on, all the way up to 20. So there should be 20 altogether. Get my pen to cooperate. It's 20. How many are in set B? 2. How many are in set C? 1. Okay, that was easy. Now, how many are in the intersection of A and B? So you look at A and you look at B and say, what elements do they have in common? Well, these are numbers, those are letters. They don't have any in common, so that means this will be 0. What if I said A or B? Union means or, so I'm looking at the 20 numbers here and the 2 letters here, so 20 plus 2 makes sense. That would be 22. Now let's go A intersects C. What do they have in common? Well, even though you don't see it, there is an 8 in here because it's 1, 2, 3, and so on, which would include the 8 all the way up to 20. So there's 1 in the intersection there. And now how many are in the union, the number in the union of A and C? Okay, if you're not careful, you're going to put 21 because you say, well, I had 20 here and I got 1 there. But the problem is you would be counting the 8 twice. So the number in the union is going to be 20. You only count the 8 one time. Now, here's what we're going to get into. There's going to be a formula for the number in A union B. To get this 20, we simply took the 20, that's the 20 in the first set, plus the 2 in the second, and that gave you 22. So what happens down here when we're talking about A union C? Now I'm talking about the 20 here, and I got 1 here. Why didn't we take the 20 in A and add the 1 from C? And the reason, of course, I already told you, is that we'd be double counting. So thinking I was 20 plus 1, but I got to subtract 1 because I double counted, and that gave me the 20. So I'm going to give you a formula here in a minute. The number in A, let's go back again. I'm getting ahead of myself. The number in A or B will be equal to the number in A plus the number in B minus something. Well, we've got to subtract the number that are in both of them, right? The ones that repeat. And that is the intersection. That would be the number in A and B. I hope that makes sense. So when you look at this problem, that 0, that's A intersect B, and this one here, this is the intersection A and C, that goes right here. So if you think about it, this is the number in A plus the number in C minus the number in the intersection gives you the 20. Up here, it was the number in A plus the number in B minus the number in both of them. Well, that was 0, so that's why that came up to be 0 again, or ended up being 20. So there's no change. So when there's an intersection, you have to subtract. Okay, that's your intro. Now, let's say you're given this problem here. This says the number in the elements of A are A, C, and D, and the elements of B are B, E, F, and G. And we want to find the number in A union B. Okay, so we can look at this and say the number in A is equal to 3, and the number in B, pen's starting to lose out. That was a good pen too. You ever do that? You get used to a certain pen. Here, let's go back to my blue in here. So the number in A is equal to 3, and the number of B is equal to 4. So does that make this equal to 7? That's the question. Okay, well, if I was just going to find A union B, kind of going off to the side here, and let's say I just wanted to write them all out, I could do that. So A union B, you know you've got an A. Okay, we're going to have a B from the second one. We're going to have a C from the first, a D from the first, an E, an F, and a G. So that means the number in A union B would be equal to 1, 2, 3, 4, 5, 6, 7. So it was 7. 3 plus 4 gave you 7. But as you've already found out, you cannot just add them together. And in this problem, I only have 3 here and 4 here. That's a pretty easy problem. You could easily write your answers out and come up with that. So here's what I'm going to suggest. Okay, it's kind of like starting over again. The number in A is going to be 3. The number in B is going to be 4. And then let's consider the number in A intersect B. This is an easier set than what we did up here. So I got A, C, and D. Here I got B, E, F, and G. What do they have in common? Well, they don't have anything in common, so the number would be 0. So if we use the formula, the number in A union B will be equal to the number in A, which we now know is 3, plus the number in B, which we know is 4, minus the number in the intersection, which is 0. 3 plus 4 minus 0 is 7. Okay, so here's the whole point. When I gave you this problem, yes, you could have written all of them out and got the answer. That's fine. But we're going to have bigger, I'm going to call them bigger, badder problems, where maybe we have 20 elements here and 30 over here. I don't want to write all of the union out. But I can easily count up numbers and come up with these. And if I know those, then I can use that formula to get the answer. That's why we have this. Okay, and that's using the fundamental counting principle. The number in the union of A and B is equal to the number A plus the number B minus the number of A intersect B. So it's a trick to help you work the problems. Okay, so we can get out of that. Let's go to the next one. Same type of problem. So set A is the set whose elements are A, B, C, D, and E. And set B are the elements B, D, F, and H. And I want to find the number in A union B. Okay, now we're going to use our formula that I got here. And we're simply going to say, how many are in A? That's easy. All I got to do is count them up. A, B, C, D, E. There's 5. How many are in B? 4. How many are in the intersection? So by simple inspection, okay, there's no A over here. There is a B in both of them. So I got a B and I got a B. C's only here. I do have a D in both of them. And that's it. So the number in the intersection is 2. So to work this problem out, if I want the number in A union B, all I got to do is plug the numbers in. The number in A is 5. The number in B is 4. And the number in the intersection is 2. And the answer is going to be 7. So what I'm trying to do, I'm trying to steer you towards using the formula, because in the long run, some of our problems are going to be harder and you're going to need to do that. Okay, let's look at a different situation. Let's say I have this one. Okay, so I've got a Venn diagram. I'll make these darker for you. I've got A, B, C, D's right here, E is right here, F is right here, and H. Something happened to G, I guess. You'll notice these are the same things we had up here. So set A has A, B, C, D, E, and B is going to have B, D, F, and H. And then the intersection would be B and D. So again, if you look at circle A, there's 5 of them there. And you're going to have 4 of them in B. And then you're going to subtract the 2 that's in the intersection. There's your 7 again. So that gives you a picture of what it looks like. Okay. I think you'll agree this isn't really tough. You watch this a little bit, it'll make sense to you. Okay, so I've been doing all of this. Now we've got a problem you're going to have to think about. This is a consumer beverage survey. A survey of 100 coffee drinkers found that 70 take sugar, 60 take cream, and 50 take both sugar and cream with their coffee. How many coffee drinkers take sugar or cream? Notice the or means union. The and right here means intersection. And that's always going to be true. Okay, so let's write down what we know. The universal set is going to be 100. That was this number right here. There were 70 that take sugar. So if A is sugar, I got 70 there. That takes care of that number. 60 take cream. Forget what I put there. How many take both? There's 50. So I want to find the number in A or B. Remember, A is equal to sugar. B is equal to cream. So A and B would be sugar and cream. A union B would be sugar or cream. So now you're seeing the importance of of and and or. Okay, so going back down here, I want to find the number. I don't know if you can read this or not. I want the number, I'm just going to rewrite, A or B. And to do that, I'm going to use the formula. The number in A union B is equal to the number in A plus the number in B minus the number in both. So if I plug the numbers in, the number in A was 70, plus the number in B was 60, minus number in both is 50. 70 plus 60 is 130. 130 minus 50 is equal to 80. So what that means is 80 people drink coffee with either cream or sugar. And when I say or, that means they could have been cream, it could have been sugar, or it could have been both. Okay. Okay, now I'm going to put another question. I want you to think about this. How many people who drink coffee can't write do not use cream nor sugar? How many people who drink coffee do not use cream nor sugar? Well, the answer is going to be 20. And you might say, well, where'd that come from? Well, we knew from right here that 80 people used at least one of them. And from the very top, we had 100 people altogether. So if you take 100 minus 80, that gives you your answer. Okay, let's look at it as a Venn diagram. And this, I'll do this because this may make a little more sense to you. Okay, so my Venn diagram is going to look something like this. It's going to have two circles. One is going to be, I know it's A, but I'm just going to write in here. You got one for sugar people, you got one for cream people. U represents the whole thing. When you fill out a Venn diagram, always start on the inside. So we're going to start with this little, what I call the overlap area, or a football-shaped area. Okay, that's going to be the 50 people right here. 50 people use both sugar and cream. If you go back to, let's say, the 70, 70 represents the people that use sugar. That means in this circle, altogether there's 70 people. But I've already accounted for 50 of them, so if you take 70 and subtract 50, you got 20 there. For the cream, we know there's 60 altogether inside the circle. I've already used 50 of them. So that number is going to be 10. And then remember, in the universal set, at the very beginning, there was 100 people altogether. So if I take the 100 people I started with, and I subtract the 20 in that area, minus the 50 in that area, minus the 10 here, that means you got 20 out here. my original question here, when I found the 80, was everything inside the circles. If you take 20 plus 50 plus 10, that gives you the 80. There's 80 altogether. Now, I didn't do it that way. I used the other formula. The second question I asked right here, I'm asking how many didn't use either one. So I'm talking about how many are outside the circles. That would be this one right here. So if I take away all of these from the 100, that gives you 20. Okay, that gives you some things to think about. That's going to finish section 5.2. I would have, in the past, I would have had 5.2 and 5.3 together. But 5.3 is going to be some harder problems, so we'll keep them separate and then go from there. Okay, that's it for now.